guys, welcome to one more video from the GMAT guy. It's a concept video. We're going to be looking at work rate problems as a follow-up to what we were doing with speed, distance, time. This is going to be work rate time. So the key thing to remember here, work rate time, there are two small things, and then we'll quickly look at how to solve a problem, right? So the key thing is work is equal to rate into time. Okay, same as speed, distance, time. Rate is equal to work over time. That's what I meant. And just remember this. Okay, when two people work together, their speeds get add up, and that's all we need to know. Okay, if work is the same, then rate. If work is constant for the same work, rate is inversely proportional to time. Rate and time are speed and time are inversely proportional, which means the faster as somebody works, the lesser the time they take. Okay, all right, so with that in mind, let's look at a problem. Here also, by the way, the approach is same. Always draw a table of work, rate, time, okay, and then go about solving the problem. Make a table, fill your data, and you will be able to solve it faster. All you need to know is that these two multiply to give you the work, okay, or in other words, this. So these two, number here, they multiply and they give you a number here. Okay, so it's kind of systematically arranged. All right, let's see how it works. Let's say if you have a problem like this. Pipe A can fill a tank in 18 hours. Okay, so what I'm going to do is I'm going to start drawing the table. Work, rate, time. Pipe A can fill a tank in 18 hours, so 18 hours. All right. Pipe B can empty the tank in 12 hours. Okay, so B is going to be negative, A is positive, it's filling. Okay, that's one crucial thing to look out for. That was tricky. Okay, and can fill the tank, so again plus in 6 hours. It's the same tank, right? So the work is the same for these three guys. Okay, so now you can see that 6, 12, 18, which means they have like a proportional speed at which they work. So 18, 12, and 6, what's the common multiple? 36. Let's say that the work is 36 units, right? Then the rate would be 6 for pipe C. Pipe B would be -3 because my work, it's emptying, right? So remember, just to make it empty, I know that it's emptying, I have to make a negative speed. And 36, okay, 2. Good. Now the tank is already filled up to 1/6 of its capacity. Good. So if 36 is the capacity, then 1/6 of 36 would be 6. So 6 unit is already filled. Great. Now pipe A is opened in the first hour alone. All right. Okay, fantastic. So pipe A is open in the first hour. So first hour, I'm just going to write 1. Time is 1 hour. I know the speed of A is 2. So work done will be 2 units. Great. Pipe B is open for the second hour. So second hour, I'm just going to write it this way. 1 hour, speed would be -3, which means the work done will be -3. All right. And then for the third hour, pipe C is open for 1 hour, where the speed is 6. Work done would be 6. All right. And this cycle is repeated until the tank gets filled. How many hours does the rest of the tank gets filled in? Fantastic. So what I'm going to do is this block here is getting repeated, right? So I'm going to bundle it up. So in these 3 hours, what's happening? What are we noticing? The total work done, the total filling up, how many units is getting filled up? 2 plus -3 plus 6. So we have 8 minus 3, 5 units. Okay. So 5. In 3 hours, 5 units are getting filled. How many do we have to fill? Well, 1/6, the 6 units is already filled. 2 fill, we have 36 minus 6, which is 30 units. All right, fantastic. So we have 30 units to fill, and every 3 hours, 5 units are getting filled. Great. So 3 hours, 5 units are getting filled. So to fill 30 units, how much time would it take? Now notice, this is time, and this is work, and time and work are directly proportional to each other. So So the ratio is that 5 times, if 5 times 6 is 30, then the time taken should be 3 times 6, 18 hours. And that's it, that's the answer. And that's how you do work rate time problem. So this was a slightly complex problem. They tried to trick you into, one was filling, two pipes were filling, the third one was emptying. But if you start arranging them in a table like this, then you're able to see what needs to be done. And note also, one more key thing here, the trick is that I looked at 18, 12 and 6 and I took the work as a common multiple so that it's easy to divide, right? Now this is not absolute, but speed, rate and time are proportional here because the work done is qualitative. They just say that the tank is filled. Now this tank, how much volume is it, we don't know. So we can actually use a number like 36, a fictional number which we have come up with, to represent the whole tank, and it works. And that's what you have to do in most of the work rate time problem. All right, so I hope this video helped. Try it, apply it in other questions, and you will see that the better you get at it, the easier these problems will seem. Once you have mastered this table and using fictional units to represent work and looking at the proportions between work rate and time, you will be able to see how effective this method is. All right, thank you so much for watching. See you in the next video. Bye bye.